Hello, and thank you for joining us for this session of the MPC Data Privacy and Security Conference. I'm Frank Wiener, Chief Marketing Officer for Sepior and founder and president of the MPC Alliance. Today, I have the pleasure of moderating a panel discussion which introduces secure multi-party computation and discusses some of the practical capabilities and constraints and considerations when applying MPC to practical business solutions. Joining me today are some of the industry's most esteemed leaders and visionaries from two companies with some of the deepest roots in the practical application of secure multi-party computation. Ivan Damgard, a world-renowned Danish cryptographer, widely known for the Merkle Damgard construction and Damgard Urich crypto system. Ivan is a man with many hats. He's a professor at the Computer Science Department at Aarhus University and is a serial entrepreneur who has co-founded multiple companies which include Partisia, Sepior, and most recently Partisia Blockchain and others. So welcome, Ivan, and thank you for joining us today.
Thank you.
Jakob Pagter is CTO and co-founder of Sepior, and Jakob is previously the head of security lab at Danish Research Institute, Alexandra Institute. Now, he's also a member of the Danish Council for IT Security and the Committee for IT Security at the Confederation of Danish Industry. Having previously served or earned a PhD under Professor Damgard's mentorship, Jakob was part of an elite team of cryptographers that are recognized for implementing the world's first commercial application of MPC in a production environment. So welcome, Jakob. In fact, Jakob, Ivan, and our next guest, Kurt Nielsen, were all members of that same first production deployment of MPC. While Ivan and Jakob focus more on the technology and secure, scalable implementation aspects of MPC, Kurt approaches MPC from the perspective of its role and use in economics and information management. And Kurt is the co-founder and CEO of Partisia and Partisia Blockchain and other companies where he also co-founded Sepior. With a PhD in business economics, Kurt's background included studies at the University of Copenhagen, University of Toronto, and UC Berkeley. And in his studies, he came across MPC, saw the potential to dramatically enhance business, and has been a passionate advocate of MPC ever since. So welcome, Kurt.
Thank you for having me.
Our last panelist is Ahmet Tuncay, and he's the CEO of Sepior and, again, a serial entrepreneur. And Ahmet has been with Sepior since 2016, where he's led Sepior's initiatives to introduce the world's first cloud-native key management as a service offering and the world's first MPC wallet to secure digital assets in the realm of cryptocurrency. Ahmet has a history of entrepreneurship as the president and CEO of Sooner, which was acquired by Autotask, and multiple roles leading product strategy and executive management for several startups in cloud, wireless, and networking domains. Welcome, Ahmet, and really thank you all, everyone, for joining us today.
Thank you, Frank.
So the reason for pulling this panel together is to explore the role of MPC in providing new opportunities for companies to improve their data privacy and their data security practices. And ideally, we want to do so while simultaneously enabling greater collaboration with third parties and reducing the dependency on specialized hardware or secure enclaves or third parties. Ivan, let's start with you. You clearly have the longest history in working with MPC. Would you mind kicking us off with a basic introduction to MPC and how it can be applied to help maintain data privacy and data security?
Yeah, thanks. Yeah, I mean, the history goes back to the late 80s or something, so it's quite a few years. Let's imagine that we want to do some computation. Let's say we have some numbers that are input, and the goal is to find the maximum, find the average, something like this. But we want to do this computation in such a way that we can make sure that none of the input numbers are revealed to anyone. Even if people have access to some parts of the computation, the only thing we want to reveal is the actual, say, average of the numbers, for instance. Mm-hmm. So clearly, if we would just involve one computer, put all the numbers in there in the way we just usually do that, then as soon as that gets broken into this computer, then everything is revealed. So that's not an acceptable solution. So what we have to do instead is to involve usually several computers, some encryption technology, just intuitively speaking, we would input the numbers in encrypted form, and we will compute on these things while they are encrypted, even though that sounds a little bit weird, that's actually possible. And then we would decrypt the final result, simplistically speaking, because that's the only thing we decrypt. That's the only thing that's actually revealed here. And the reason why this is sometimes a useful thing to do is because think, for instance, of like, a typical benchmarking scenario. So you want a company in some line of business, and you're naturally interested in how well you're doing compared to your peers in the same line of business. So there's a whole bunch of parameters like productivity or turnover, whatever, that you want to compare yourself to the others on. And that kind of scenario is quite typical. It's typically a service that everybody wants, but nobody wants to give input to such a service if it was a single person doing this kind of thing, because, the data that is needed for this analysis is exactly the data that you don't want your competitors to get to know about. So there's obviously security risk here. So on the other hand, if we had a good MPC system, that exactly solves this problem, right? It lets you make sure that you can give your data to the system and make sure that they're not revealed, even if they're private data. And on the other hand, at the other end, you actually get this analysis result that everybody wants it to see. So that's kind of intuitively what this thing accomplishes.
Excellent. Anybody else on the panel want to add to that or add any other perspectives?
Maybe some comments, a different way to look at it. So it's kind of a new approach to data privacy. So you're solving conflicting objectives. So on one hand, you want to bring data to use, and you want to actually use more data in order to sustain the data-driven economy. On the other hand, you also want to protect data even more to reclaim and control of your bargaining power or simply your privacy as an individual or company in the economy. So meeting these two conflicting objectives, that's exactly what you can do with this technology. That's why it's so powerful.
I agree. And as I mentioned in an earlier conversation we were having, as I think about MPC, it's not just about improving the privacy or the security, but it's really about enabling new capabilities, things you couldn't do before, and still be able to maintain the privacy and security. Then moving on, let's see, the next question I've got here is, what are some of the specific examples of where MPC can be applied, again, to solve real-world security and/or privacy? So we talked generically about it, but what are some specific examples? And I know, Ahmet, with you leading up Sepior, focused more on security, and Kurt, you leading up Partisia, focused more on the privacy. You guys are going to bring two different perspectives. So Ahmet, why don't you kick us off on this one?
Yeah, of course, Frank. I think the real benefit of MPC is that it allows you to really perform computations on data that's obfuscated or encrypted. And I think this is what Ivan and Kurt were saying. You can do computations on data, in secret data, and guarantee that the output is correct, but nobody knows the inputs, and this is a very powerful concept. So what we do at Sepior is we look at all of the pieces of information that really should be kept secret. This is the most essential thing to businesses. And of course, it's sort of obvious that in the business of data protection and security, key management, cryptographic key management for encryption, decryption is sort of the most essential piece. So we're very much focused on all the different ways cryptographic keys can be managed in all sorts of different settings. So we started on this journey back in 2014-15 timeframe. And in around 2016, we launched a key management as a service. And this was the first cryptographic key management, cloud native, cloud first key management system. It essentially solved a big problem for businesses, which is, how do you manage the keys that you use to encrypt and decrypt data in different clouds? The way we sort of described it at the time, of course, this is going back a few years, was multi-cloud, bring your own key. So the idea of being able to let businesses generate and use their own keys in multi-cloud settings as a service and not having to own their HSMs and so forth was a big step. And I think this really woke people up to all the possible things that you can do with MPC in a real pure cloud, pure software setting that can replace heavy iron, like big HSMs that have been in these systems for decades. And we can fast forward from that to a few more years into 2018 or 19 timeframe when the world got into the business of digital assets. We generally call them cryptocurrencies, but not a whole lot of them can be called currencies. But the idea of protecting a digital asset is the same as protecting a piece of data. You basically have private keys to manage, public keys to drive from those private keys. Transactions are signed. An ECDSA signature, for example, is kind of not that different than trying to figure out the average of a bunch of different numbers. It's just a computation on encrypted data. Of course, the problem at the time was that a secure hot wallet did not exist. People kind of knew how to build cold wallets and air-gap wallets and things like that. But MPC basically allows us to build operational wallets that are hot, cold, warm, whatever you want to call it, and provide a high throughput rate, slow latency, air-gap signing. All sorts of innovations have been done in that market for a long time. And today, we're really taking those concepts much further into advanced forms of policy enforcement. Basically, if you think about a policy is a quorum. You get a bunch of people, a certain number have to approve something. That's really a threshold problem, a threshold cryptography problem. So we're now building policy-based wallets based on MPC. So it's a short story of how a company like us can take the concept of an MPC and contribute in many different ways to different problems in IT, data security, data privacy, and the future is quite bright for these technologies.
Excellent, excellent. So basically, the idea is keys are used in a broad range of applications, and with MPC, you can find ways to keep those keys secure without the heavy dependence on HSMs, the way we have in the past, and allow for more creative approaches.
Of course, private key management use generation is probably a tiny subset of all the problems MPC solves, but it's one that's very relatable in our role today.
Sure.
Because if things are not encrypted, just expect them to be compromised.
Sure. Excellent. Okay, thank you. Kurt, how about from the privacy perspective?
Yes, so this is a different class of problem where we are basically using the technology to replace what is known as a trustee in the economy, a person, a service that is holding data from different parties and solving a problem. So yeah, usually talk about some different classes of problem. One is where you use the technology for an individual to reclaim control of data while still using the data in a data economy. Another class of solution is where you use the technology to bring collaboration in place among competitors or across other legal boundaries. So maybe some examples of this. So we started the whole commercial use of MPC started by replacing the trustee the auctioneer as a trustee in market solutions. And recently we've been doing the same for what is known as financial order matching or dark pools, where MPC is basically running the matching service and keeping the bids and asks confidential throughout the process. Other examples, if we look into the data economy or data exchange, could be a project like instars.com, where we built the infrastructure and facilitating that an individual with his phone can keep his private data confidential and still bring these data into a data economy and not sell the data as such, but sell the use of the data, which is sort of pivoting or changing the powers in the data economy. So you can basically, as an individual, sell you the use of the data again and again.
Yeah.
And you keep in power in the data economy. So that's sort of the key sort of economic driver in this type of economy. But also the whole thing about reclaiming control of data while it's in use is enabling maybe a class of my data's solutions, or maybe you could go to the advertisement business engine of the entire internet economy and bring a more direct connection between the individual users and the people that is selling goods and services, and cut out the middleman in between. So that's what we are working on with a new search machine that is aiming for privacy, called Better Internet Search. And we can move that further to tackle advertisement in general. But there's even more like important issues that we are working on, which is the whole class of decentralized healthcare, where you can go into a developing countries where they don't have a developed infrastructure for healthcare, and you can actually use the existing infrastructure and establishing a healthcare system based on the existing investment, just basically bringing in software and use the existing hardware investments by the citizens in these countries. So that's just some of these use cases.
No, that's perfect. That's perfect. And you've actually kind of led into the next question. We'll open it up to the whole panel. But obviously, things have been happening for a long time prior to MPC being a part of the overall solution. So there are clearly existing alternative technologies to MPC. But what are some of the problems or the undesirable characteristics of existing alternative approaches that people can think of as MPC is going to help them get away from that burden they've always dealt with and just kind of accepted that's the way it is? You know, what are some of those examples that we want to bring to people's, conscious awareness?
So one example of that, I guess, would be if we go back to this benchmarking analysis thing I was talking about before. So we have different companies who want to compare themselves, to benchmark themselves against each other. The way this was done often in the past was that you have some consultancy house coming in, and they say, okay, you have to trust us, you give us all your data, and then we do the analysis and tell you back the results. And we stake our good name and reputation on you have to trust us that we will not sell your data to do anything else that will be harmful to your privacy. So what happens in this kind of a solution, of course, is that you must pay some fees to the consultancy house to get this done. And in some ways, if you're in a somewhat unkind interpretation, this is kind of a counter-bribe, makes sure that the consultancy house has incentives to do what they're supposed to. Now, what you can do with MPC is, on the other hand, you develop a software and maybe software and hardware system that will do the same with the same security guarantees, but in such a way that you just develop the system once. And even if this might be, a lengthy process where you have to make sure the software does exactly what it's supposed to, the point is you can now amortize the cost of this whole system, developing it over a whole bunch of applications, because once this is done, you can run this analysis every year without having to pay the yearly fee to the consultancy house. And at the end of the day, therefore, it's actually good business.
Excellent. Anyone else have any other input or examples on that? If not,
in the category of all the things that you can do with MPC that you could not do before, I'm sure that there's just tons of stuff, but I think with MPC, what you end up finding is that you can do things in a much more efficient way, operationally aligned with what the business needs to do. Mm-hmm. Minimize, investments in hardware and infrastructure. And of course, there's probably a category of things that might not have been possible at all,
right?
That you can now do. But it always seems to boil down to eliminating a single point of trust, which is generally a single point of failure. If you can distribute the computation and the trust over a number of different parties, and sufficient number of them are honest, and not everybody needs to be honest. One of the things that IT people are really surprised to understand is that in traditional IT systems, you're as good as your weakest link, which means you should not have any weakest links. Everything has to be properly secured. You have to run the right, the right version of code and the right hardware setup and whatever. So there's zero toleration for malicious actors in most systems. But threshold cryptography, threshold MPC has the interesting property that some of these actors can actually be corrupt or just not available, maybe malicious, whatever, and you can still guarantee a correct result, and also guarantee privacy and secrecy. And I think this is the thing that's now possible. It's a rethink of how we view security systems.
But yeah, I agree with that, Ahmet. Two good points. I also think that, going back to some of the stuff that Kurt mentioned and that you were asking about, Frank, that there's stuff that we can do now that might not have been possible before. It's not in the sense that you couldn't do it, but you can think of MPC as a technology that can lower risk and cost at the same time. So for certain things, for instance, in supply chain management, there might be certain information that you don't exchange between different actors in the supply chain because they don't want to divulge that information, or the benefit of it does not meet the risk. And the risk is too high, but if you at the same time you can reduce the risk and the cost, then actually you get a very nice system where you can solve problems which were not cost efficient to solve before.
Yeah, no, I agree, Jakob. And one of the things that's coming to mind, and one of you mentioned earlier, GDPR, and what resonates with me and Kurt with the healthcare example is with GDPR there are constraints on what can be shared, but with MPC there's a potential to where you can share the use of the information derived from the data without actually sharing the data. So I tend to think there are things we can do that GDPR would prevent you from achieving certain outcomes based on historic approaches, but with MPC you can get there. And Jakob, since you chimed in, and we're talking about all the great things MPC brings to the party, and I think that's really why anybody cares. But every technology has its limitations and its operational attributes that don't come for free. And I think it's important for us to acknowledge that MPC is going to have some technology attributes that need to be considered when people decide, okay, I've got multiple options, MPC is one. Is MPC going to be the best one for this particular use case? So, what are some of the things that people should be aware of and think about when they consider using MPC that might not exist with some of the approaches they conventionally have? And maybe, Jakob, you can kick that off and we can open it up to the whole panel.
So you're asking about what type of considerations you should do before you use the technology, or? Yeah,
exactly. Well, for example, like with multi-party, we know that it's more computationally intensive than just open.
So there are different. I guess there are different problems that you need to consider. Some are technical and some are business problems. At a very high level, I think performance is an important thing to consider. For some cases, it's just the technology is still not performant enough. It's several orders of magnitude faster today than it was when we started commercializing this 10 or more years ago. But still, for some use cases, it's just not performant enough yet. So you need to take a look at the use case you have in mind and consider whether actually, for instance, you might be running on networks with huge latency and stuff like that, which might impact the usability of the solution. On the other hand, you also need to consider whether the trust model offered by MPC, in particular, in a way that matches other of your requirements, whether that actually aligns with the threat model you have for the system you're building. So I think one of the great flexibilities about MPC is that you can align it with many different threat models, but in some cases it just doesn't make sense. So you need to sit down and consider that. And then I think one of the last things you need to look at carefully is that this is a novel way of doing cryptography, at least in terms of software and commercial software. And in all types of cryptography, it's really, you need to be careful about how you use this type of solution. So you need to make sure that you use suppliers that have a great deal of experience in working with these technologies and know some of the pitfalls. For instance, in cryptocurrency wallets, recently there have been a number of exploits based on poor implementations. And you need to consider that kind of problems too, that are you working with a team that has a sufficient track record with the technology?
Exactly.
Yeah. I have maybe a supplementary remark. Jakob is right, of course, that there are limitations, particularly because if you have a system that's based on several different locations working together, this really is a multi-party computation. Typically, the network will be the bottleneck, because you cannot really get security without communication, and much more communication than you would have to do with ordinary computation, with insecure computation. And we know that in some cases that overhead is simply not avoidable. But we are getting much better at this. To give some perspective, sort of very rough perspective, some people have tried to benchmark, the best MPC systems out there against sort of, let's say, ordinary computation. And sort of very roughly speaking, the speed we can do secure computation at today is sort of very roughly comparable to the speed of an Intel 8386 processor, that we had in the PCs from the 90s, which of course is much, much slower than what we can do today. But on the other hand, I mean, we were happy about those machines back then. We could do quite a few things there. So, we had a point where we can do lots of useful things, but we can't do everything.
Right.
So what that means is that in many cases, what we have to do is to be smart and say, well, if the computation is too big to do the whole thing securely, we have to figure out which parts can we do securely, and then figure out, well, maybe if we leak some pieces of information, we can actually show that's not really crucial at all to our security overall. So therefore, we can actually optimize the thing this way.
Excellent. Yeah, and I mean, you're kind of led right into the next question that I had, which is, what are some of the optimization approaches available to maximize the performance and the efficiency? And clearly, you just described one, and I know in the case of Sepior, kind of pre-processing is one of the techniques we're using to minimize any kind of delays associated with the computation and communication. But I just kind of touched on those. But anyone want to elaborate a little bit further on the fact that what you just highlighted, Ivan, that there are opportunities to optimize, to overcome what might be kind of some of the default limitations?
I'll just comment.
Okay, so yes, please go ahead.
Yeah, I mean, this is probably more of a peripheral comment than Kurt, you can pick up. One of the things that we find is that in certain segments like fintech, regulation always seems to lag implementation and engineering. and what often happens is that you see scenarios where, for example, in order to implement a cold wallet in certain jurisdictions, you must be able to sign a transaction in an air-gapped machine. And one of the optimizations of MPC, of course, in our field, has been as you mentioned, the ability to pre-generate signatures on different nodes of different participants. And the optimization that you get is that these signatures are not tied to a transaction when you first create them, but you're able to mitigate the multiple rounds when you're actually doing an actual computation, like to create a signature, for example, or compute some average. And of course, it turned out that it had some other unintended benefits as well. One of them was not only that could you participate in an MPC computation while air-gapped, but you also, by reducing the number of rounds, you can sustain very high throughput rates. And in some cases, these rates approach those of traditional payment rails quite high. So I think engineering is always able to fix these problems, given a good understanding of the environment and the use case, and in some cases regulation. So I think the opportunities are quite large.
Yeah, and it's not just engineering. I think some of the, at least in my experience, some of the great achievements we've accomplished have been based on a close collaboration between university researchers like Ivan, seasoned applied cryptographers and software engineers, and people with a close and intimate knowledge of the business domain, because you really need to align all those things together. And sometimes you can make certain optimizations for MPC solution, which you didn't think was possible, but made it work in practice because it made it sufficiently efficient. And to do that, you need to know how to implement that in software. You need to have the theoretical insight to understand whether it's still secure, whether there's some protocol-wise shortcuts, mathematical shortcuts you can take. And you need to be sure that you understand the business model precisely, so that you can align the MPC and how the secret sharing and different players in the protocol are laid out. And once you do that, it often turns out that you can actually achieve something which is, at least in all the cases we've been working with, turns out to be actually have practical solutions. And I think that's really an important approach, that you combine these different skills and not just have a set of great programmers or a set of great business developers, but you combine these and have these people, at least from time to time, in the same room, so that you can work out some good solutions.
Excellent. Kurt, did you have anything to add? Or
yep. Just to add to that, what Jakob just said, so that was actually also my point, that the MPC is kind of a new tool in the toolbox. So we've been doing a lot of sort of confidential statistics. So there are ways to get around privacy, other ways to do that, like differential privacy, pseudonymization, federated computation. But if you look at any of these type of these tools, MPC actually adds to that and makes it either more simple to use MPC, or makes federated computation more generic. So I think this interplay between these existing tools that solve for privacy is key.
Perfect. Well, just unless if anybody had any further comments. The last question I was just going to ask is just a wrap up. I mean, I know we've covered a lot of ground, but any parting thoughts or things we want to share with the audience before we wrap up?
Yeah, well, maybe just as a supplement to one of the last things that was said. So the importance of getting different expertises together, because optimizing MPC, it's sometimes not just about doing better at the binary level and trying to optimize your code. It can also be something that depends on the application. So what happens is typically that if you try to keep everything private, so all your data is encrypted all the time while you compute, it goes slower. If you can afford to have some of the data be public, you typically save a lot in efficiency. So then what can you afford to make public? Well, sometimes if you think about what you're doing, it's actually the case that since you know that the final result is going to be public anyway, some of the intermediary results can sometimes also be public because they follow anyway from the end result. Very simplistic example, if you're computing an average, say some people want to compute the average of their salary. So, I want to find out if I'm earning much less than the average of everybody else here, right?
Right.
So you take 1,000 numbers as input, you add them all, you divide by 1,000, and then you output this, right? But the thing is, this division by 1,000 is not really necessary. You might as well just reveal the sum of all the numbers, right? Because since the average was going to become known anyway, if you know the average, of course, you also know the sum, just multiply by 1,000. So there's no need to do the division by 1,000 inside this encrypted domain. You might as well just compute the sum.
Right.
Not exactly rocket science, but just to get the point across.
Exactly.
And the point is, for this, you actually need someone who knows about MPC and someone who knows about the application as well.
Excellent. Well, again, we've covered a lot of ground. I want to thank you all for sharing your insights. Just to kind of summarize and wrap up, you know, what I'm seeing and hearing and experiencing being in the business is that MPC is real and it's ready to be applied today. And it not only can it introduce better solutions in terms of, you know, improving security or improving privacy, but perhaps more importantly, it can also enable new approaches that yield better outcomes overall for businesses. So I think that's kind of a really important key takeaway. Having said that, I think what we're acknowledging is that MPC isn't magic. You're not going to wave a wand and everything just magically happens. A lot of care has got to be taken to make sure it's implemented properly with best practices across the security stack to achieve both the optimizations that you were just referring to, Ivan, and just to ensure security and privacy is maintained throughout the whole process. So as you're engaging in MPC, we invite and encourage you to engage with companies that, you know, have a deep history and that you can rely on and trust in this domain. Any other closing comments for anyone, or we can call it a wrap?
You know, Frank, just what you just said reminded me as when you said MPC is real and has you know, very large number of relevant use cases in our role today. And you know, the calendar says October 2021, and in certain in certain areas like digital assets and digital asset management, like NFTs and STOs and stuff, I mean, MPC has sort of become the de facto way to build these systems. So it's not just a shot, it's not just a sideshow or an optimization. It's basically the way to do stuff.
Right.
And finally, some of the standards efforts in this area, like NIST and even IEEE has a working group on standardizing certain more basic threshold MPC operations. So, and once standards start to mention these technologies, then you kind of know where it's all going. But this is as real as this gets, and it's a pretty exciting time to be involved in this technology.
Yeah, it is. It is. Yeah, I mean, we've literally in the course of the past, I think maybe 18 months, we've seen MPC really transition from a fairly limited number of deployments to literally hundreds, if not thousands, of companies are now transacting with and using MPC in the background, and major companies, you know, like Facebook and Google and Apple and others are beginning to use MPC in their big mainstream operations. So we look forward to seeing this technology be adopted more broadly throughout the industries. And again, I just want to thank everybody, thank our panelists, number one, for joining and sharing your time and insights, and everyone for joining us today. So thanks and have a great day.
All right. Thank you, Frank.
Thank you. Thank you, Frank.
Bye.